Hello, and welcome to Solving Equations by Factoring. So we have this thing called the zero factor property, and the amazing thing about the zero factor property is it tells you exactly what to do, and we'll get to that in a minute. But it says if a times b equals 0, then either a equals 0 or b equals 0, or both. Now, this is special about 0, right? Because if two numbers multiply to be 4, could be 2 and 2. It doesn't have to be 4 times something else, right? 4 times 1. But 0, if you multiply to get 0, one of them had to be 0 or possibly both. That's it. That's the whole property. And there's so much we could do with this. So here's the steps to solving. Set the polynomial equal to 0. Then factor it completely. And then use the property. Step 3, set each of the factors equal to 0 and solve. Always check your answers in the original. Zero factor property tells you exactly what to do as we're solving these. So we're equal to 0, and I'm going to write the steps. 0. We're going to factor. Already done. So now we use the property. The property says that the first thing, x minus 2, could be 0, or the second thing, x plus 3, could be 0. Now we solve these two equations, x equals 2 or x equals negative 3. Let's check. If we use 2, right, we have to use 2 in both places. 2 minus 2 is 0. 2 plus 3 is 5. 0 times 5 is 0. Awesome. Negative 3. Negative 3 minus 2 is negative 5. Negative 3 plus 3 is 0. Negative 5 times 0 is 0. They both work. Fantastic. Let's do another one. All right, 0, it's equal to 0. Awesome. So let's factor. I know, how can someone sound so excited about factoring? That's just how I roll. It really is. When I factor an x squared, I know that'll be x times x. I want to multiply to get a negative, so 1 will be positive, 1 will be negative. They multiply to be 4. They're different by 3, so it's got to be 4 and 1. And since this 3 is negative, the bigger number, the 4, has to be negative. So it's already equal to 0. We've factored it. Now we could use the property. And the property says x plus 1 is 0, or x minus 4 is 0, which tells us that x equals negative 1, or x equals positive 4. Notice how in the parentheses, x minus 2, we get 2. X plus 3, we get x equals negative 3. Think back to the vertex form of a quadratic, and that's a lot of that whole opposite idea of what's going on. These are called factors. That's why we're factoring it into factors. And these are called zeros. So factors and zeros are going to be very closely related. And we'll get more into that in either college algebra or pre-calculus, depending on which course you're taking. In some schools, in one of the schools that I work for, you could take either one of those. Uh-oh, I lost my cursor. Oh, I'm starting to have issues again. Here we go. That's all right. We'll go with what we have right here, right now. So first step, we want to get it equal to 0. So I am going to subtract 38 from both sides. So I'll have x squared plus 3x minus 88. Second step, I'm going to factor. Don't do that. That's horrible. This is an equation. An equation always has an equal sign, something on the left, something on the right. Don't forget that equals 0. It might not look that important, but it is one of the most important things here. That tells us what we're doing. It tells us we're looking for an x value and not just simplifying an expression. So to factor in x squared, I'll have x times x. To get a negative 88, 1 will be positive, 1 will be negative. Let me see, I want to multiply to be a negative 88, and I want to add to be 3. So I'm thinking 1 and 88, a little too far apart. To, let's say, 8 times 11. 8 times 11. If I want the 3 to be positive, the 8 is negative and the 11 is positive. Let's see. x times negative 8 is negative 8x. 11 times x is 11x. 11x minus 8x is 3x. Fantastic. We have that middle term. Plus 11 times a negative 8 does make the 88, the negative 88. Now let's use the property that says either x plus 11 is 0 or x minus 8 equals 0. If we subtract 11 from both sides, we'll get x equals 11. And if we add 8 to both sides, we'll get x. Let me add 8 to both sides appropriately. Add 8 to both sides, and we'll get x equals 8. I call that a shift error because the equal sign and the plus sign are the same on the keyboard. And even though I'm handwriting it, it's somehow just a shift error in my head. Okay, again, always, every single time, get it equal to 0. 3x squared minus 5x minus 28 equals 0. And now we're going to factor. I'm going to put my work over here. In order to factor, we need to multiply 3 times a negative 28. We'll do that on our calculator over here. 3 times a negative 28 is negative 84. So it needs to multiply to be negative 84, add to be a negative 5. Let's see. 84. I'm feeling 7 and 12. 7 and 12 multiply to be 84. They just popped in my head. Guess and check works. All right, guess and check works. Multiply to be negative, so I know one of these two has to be negative. But since they add to be a negative, I know the bigger one has to be a negative. So I'm gonna draw a little line here so we don't run into two problems into themselves here. What I'm going to do is I'm going to expand. Instead of writing minus 5x, I'm going to write it using these two. I call this factoring using the AC method. Please see an earlier video on factoring if you need that review. Never a problem if you need a review. Now I group these first two, 3x squared and 7x have an x in common. And I'm left with a 3x plus 7. I'll always use the sign in the middle. 12x and 28, they have a 4 in common. Negative 12x divided by a negative 4 is 3x. Negative 28 divided by a negative 4 is a positive 7. I see that these two terms now have a 3x plus 7 in common. And I'm left with x minus 4. So I factored. All right, I got it equal to 0. I factored. Now I can use the property. The property says 3x plus 7 equals 0, or x minus 4 equals 0. If 3x plus 7 equals 0, then 3x equals negative 7. And we'll divide by 3 to get x equals negative 7/3. And if x minus 4 equals 0, when we add 4 to both sides, I just had a shift error again. We'll get x equals 4. And again, you could check these. Always check your answers. That's the beautiful thing about math. I don't have a phone booth to go back in time and check my history, but I definitely have an equation. I could always check my answers in math. All right, let me see if I can find my cursor again. Give us a little room. Now you'll notice number 5 is no longer a quadratic. It's actually a cubic because the highest power is 3. It doesn't matter. We'd use the same steps. 0. And now I'm going to factor this, and I should factor using blue, but I'm going to just factor here. Notice that 10, 66, and 28 all have a factor of 2. But x cubed, x squared, and x all have a factor of x. So I'm going to take a 2x out of everything. That leaves me with a 5x squared, a plus 33x, and a minus 14 to get 0. So we're going to use this 2x. We're not finished factoring yet. we also need to now factor this. So I'm going to use a little scratch work here. 5 times a negative 14 is 50, and 20 is a negative 70. And I want to add to be 33. Well, that one turns out to be pretty easy. 70 is negative. I'm going to do 2 times 35. Right? Since the 70 is negative, I know one of these is negative. They add to be a positive 33. So the 35 must be positive and the 2 must be negative. So I'm going to rewrite just like I did in our last problem. Now, I'm not writing the equals 0. I don't have the 2x. I don't have any of the parentheses. I'm just going to kind of write a little bit of work here to get what's inside the parentheses, my quadratic part, factored. So these two have an x in common. I'm left with a 5x minus 2. Use the sign in the middle. 35 and 14 have a 7 in common, and I'm left with a 5x minus 2. And now the entire thing factors as 2x times that 5x minus 2 and the x plus 7. And that all is equal to 0. 0, now it's factored, and we could use the property. Now the property just said if you multiply two things together and you get 0, one of them had to be 0. But it doesn't matter how many things you multiply. The only way you can multiply and get 0 is if one of them is 0. So is 2x 0? Or is 5x minus 2 0? Or is x plus 7 0? Let's find out. If 2x equals 0, we'll divide by 2 and get x equals 0. Well, yes, if x is 0, I'll have 0 on the left equals 0. Great answer. If I add 2 to both sides and then divide by 5, I'll get x equals 2/5. We could check that answer. Or if x plus 7 equals 0, I can subtract 7 from both sides and find my answer as well. It's probably good form putting in the or because they are options, but they all three work. Right? But those are the only three values of x that will make this equation equal to 0. A great way to check that. I want to make sure this video doesn't get too long. We have 2 more examples, but I do want to show you how to check this. Checking really quickly, I'm going to put 2/5, 2 divided by 5, and then store for x. Now I could type 10x to the third, make sure I come out of the exponent, plus 66x squared minus 28x, and I can make sure that equals 0, and that's how I can easily check my answer of 2/5. All right, couple more, just a couple more. I've never had a student complain about having too many examples, so I'm just gonna do a couple more. Okay, x squared plus 13x equals a negative 36. We get it equal to 0. So x squared plus 13x, add 36 to both sides, equals 0. Second step, factor. To factor x squared, that'll be x times x. Two things that multiply to be a positive 36, because it's positive, they'll have the same sign. Because this is positive, they'll both be plus. Multiply to be 36, add to be 13. That seems like a 9 and 4 issue to me. And the property tells us that x plus 4 equals 0, or x plus 9 equals 0, in which case x equals negative 4, or x equals a negative 9. That's a horrible, horrible looking 9. Let's make that better. There we go. All right, and this is what Bugs Bunny would call the coup de grace. Here we go. Let's get this equal to 0. In order to get this horrible equation, example number 7, equal to 0, I will subtract 6x from both sides, and I'm going to line it up So I'm subtracting in the appropriate places. I'm going to add 5 to both sides. The reason I did that is to get a 0 on the right-hand side. But what do we have? We have 2x to the third plus 11x squared minus 21 and 6 more minus 27x. The 5's cancel. 6x's and 5's cancel equals 0. Look at that. We have another cubic. So I'm going to start out in black here to factor. A 2, 11, and a 27. They have no numbers in common, but I can definitely take out that x. Now, in order to finish factoring, I'm going to look at my quadratic. There's a couple of different ways we could do this, but let me do it the right way. I was going to just do it by my magic mental method. That's impossible to explain, and this video was really to explain. So let's walk through it. 2 times a negative 27 is a negative 54. So I want two numbers that multiply to be negative 54 and add to be 11. Okay. Let's just start dividing. 54 divided by 2, we're pretty sure of already. So how about divided by 3? 54 divided by 4? No, that's not going to work out. 54 does not divide by 5, but it does divide by 6. 6 and 9. Here, let me write some of these down. We have 1 and 54. We have 2 and 27. I want the 11 to be positive at the end, so I know the bigger number has to be positive. We have 3 and 18. They're different by 15. 4 didn't work. 5 won't work. 6 and 9 are different by 3. Uh-oh, SpaghettiOs. No, I'm not advertising for SpaghettiOs. Nothing wrong with them. Nothing good about them. Nothing. This is not factorable. And if this is not factorable, this is an equation that we will have to solve with another method. Now, I don't know why I would put that in my notes, so I just want to check a couple of things first. I'm going to check my minus 21, and I'm going to subtract 6. That is, in fact, a negative 27, so that's good. The 5's do cancel out. Add 5, 2 and 11. All I took out was the x. There can be no two numbers that multiply to give me 54 that are different by 11. So this one is definitely not factorable. I always like to check a second time because it makes me wonder why I would put this in my examples. But it happens, all right? It happens. That is it. I hate to leave you on that not possible one, but the homework should all be possible if you're one of my students. Most textbook math, these are going to be possible. I made a typo somewhere. That was probably a 15. Nope, it wasn't even that. I don't even know. I don't even know. I'm going to leave it so it doesn't drive me nuts. Thank you very much for listening.